Okay, all right. So here's what we're gonna do today. All right. We are going to. Okay, all right. You're probably wondering why I'm sitting like way up all of a sudden. I'm trying to represent my favorite soccer team, Sevilla. Okay, all right. So, anyways, what was I saying? Oh, today what we're gonna work on is. Did I just see a squirrel right behind me? All right. So what we're gonna do today is work on the next thing, really next and last thing in the unit. Okay, it's not supposed to be a very long unit. So we're kind of having talked about a arithmetic and geometric sequences with the explicit formula. Okay, what we're going to do today is the next part, which is the recursive formula. Okay, and as I was just going over the material, I just realized it's like super duper easy. Okay, so all right, let's go. All right, now, one of the first things that I want to tell you with this for the next 4 days, okay, hopefully less, when we're working on the recursive formula, all right, and I want to emphasize this really, really heavily, that you have to, you have to memorize this formula. Okay, all right, not the best way to start off. Okay, completely crooked. All right, okay. So you have to memorize this formula. You absolutely have, because it's not provided on the regions. All right, so let me show you, because if you look at the regions reference sheet, which is right here, have you noticed, right? Like these are explicit formulas only. So have you noticed, right? These are the only thing that mentions anything about sequences, and they're both explicit formulas that we have gone over in the last week. Okay, so today, all right, now if everything goes well, today should be Monday. All right, so this week we're going to work strictly with recursive formula, and the bad news, I guess, is that you have to memorize this formula, but the good news is it's actually unbelievably easy to understand. So if you understand it easily, I would like to think that it's easier to memorize. Okay, now what is the recursive formula, right? Okay, so the first thing is I've noticed when I was prepping for this unit is that whereas almost 100% of the formulas, right, it just involves one line, right? So for example, if the slope intercept formula looks something like this, right, and the standard form looks something like this, even something super simple like the area of a triangle, for example, right, would be base times height divided by 2, right? It's one sentence. So one of the first things I've noticed when I was prepping for this unit is that, like, this formula, all the answers, you have to list out what the first term is. Like, you have to tell the person what the first term is. And you know what's kind of funny? When you look at the questions, all the questions gave you the sequence. So if I were to give you this, right? If I were to give you this, well, the first term is 2. So it's, sometimes, when I look at this stuff, it makes me wonder why we're like doing the obvious, okay? But, I guess that's kind of convention, all right? Now, what's the second thing we gotta write down? And that is this, all right? So we have to list out a's of n, right? And then, now let's understand this first. A's of n, so what it's saying is this, all right? What this formula is saying is, hey, in order to get to the term that you want, okay, so imagine if you want to get to like the 10th term, right? So let me put it here. Imagine you want to get to the 10th term, right? What they're saying is, hey, look at the 9th term plus the common difference. That's all. That's it. That's the equation. Okay, so again, let me repeat that. Let me use a numeric example. Okay, maybe that will help. Now, right here, what we need to understand is, hey, what's the common difference? Right? So in other words, how does 2 become 4? How does 4 become 6? How does 6 become 8? And how does 8 become 10? Right? Plus 2. So the common difference is plus 2. Right? Because for every term, we're adding 2 to the previous term. And that's exactly what this formula is saying. Okay? They're saying, hey, given the first term, all right, should have used a different color. Given the first term, to find the term that you want, look at the term before and then just add the number that you've been adding all along. That's it, okay? I'll repeat. To get the term that you want here, all you have to do is look at the previous term and add the number that you've been adding all along. So for example, how would this look as an answer? I'm sure you guys are all wondering, right? Like how would I write this? What would I put on paper, right? Unbelievably simple, okay? Previous term, you literally rewrite this, plus the difference, which is 2. That's it. That's the official answer, okay? And if you want to be super duper orthodox about writing the answer, you can go like that, okay? So that would make you super sophisticated, all right? And that's how you do it. That's it. So again, what do? When you write down the answer for the recursive formula, you write down the first term, you state what the first term is, and then the second thing is, you just write the formula out. So this stays the same, this stays the same, so what's the only thing that's different? Yeah, the common difference. That's it, okay? So now let's jump right into it and let's practice, okay? And you see just how easy this is. All right, now let's take a look then. All right, so number 1, right? So again, we'll do the odd number questions. Okay, let me make sure I'm still recording. Okay, good. All right, find the next 3 terms. Okay, now, given that, that's already assumed that they all have a common difference, like because they're telling you that this is an arithmetic sequence, right? Okay, so let's play along. All right, this is plus 7, plus 7, plus 7, triple 7 for extra luck. So what's the next 3 terms? Okay, plus 7. So let's see, 1, 2, 3, 4. Next 3 terms, let's be super professional about this. Term 5, term 6, term 7. All right, so that's plus 7. So that's 24 plus 7, 31. 31 plus 7, 38. 38 plus 7, 45. That's it, all right? Now, they want the recursive formula, right? So remember what I said about the formula, right? You have to list out the first term, so I would write like this. First term is 3, and then therefore, a of n is the previous term plus the common difference, which is 7. That's it. That's how you write the answer, okay? All right, now, let me double check, because it just looks so easy that it makes me have like doubts. All right, let me double check again. Yeah, I just double checked. That's it. That's all you have to do. Okay? All right, cool. Now, I know what some of you are already thinking. Hey, Mr. Ng, why did you give us like that really hard, maybe really hard topic, right, with the explicit formula? Why don't you just start off easy, okay? I mean, to answer that, I mean, it makes more mathematical sense to start with something that's easier and then kind of build it up. But the problem also is like it's with explicit formula, it's more to the point, right? Because it takes you directly to that term. Whereas this one, we constantly have to look backwards. All right, we'll constantly have to look backwards over our shoulders, I don't know, so to speak, right, to get this formula. And so from a purely mathematical point of view, this feels a little like beating around the bush, okay? And I would rather that we just go to the most direct thing, okay? So now, as a consolation also, if you do see a question on the regions, on sequences, and you probably will, 1 or 2 questions, almost always they're dealing with recursive, okay? So I think that's the good news that we can take away from this. Okay, all right, let's move on. Number 3, this is minus 12, 7 minus 12. Yep, they're all minus 12, right? So let me write this down here. Let's see, 1, 2, 3, 4. So 5th term, 6th term, 7th term. All right, let's see. Let's see, what was I doing? All right, so negative 5 minus 12 is negative 17. Negative 17 minus 12 is negative 29. Negative 29 minus 12 is negative 41. So those are the 3 terms. And then for our formula, first term is 31. And so to get the term that we want, we would have to look at the previous term minus 12, okay? Now, perhaps I should go into this just a little bit more. So the question might be something like, hey, like, can you prove that this works? And so, sure, let's try to prove it, okay? So if the first term is 3, right? And then to get the nth term, we need to take the previous term. So for example, if we actually use this, so let's say I want the 5th term, right, which is here already, I know, right? I would have to take the 4th term plus 7. Now, what's the 4th term? 24, right? So that would be 24 plus 7, which is 31, which matches. Okay, so that's what that means, okay? That's all. Now, some of you might also say, hey, Mr. Ring, then why do I need to tell you what the first term is? Right? And that's a great question. Now, hold on. Now, you need the first term because if you don't have the first term, you can't establish what the actual number, so for example, what these 3 numbers are supposed to be. Like, you gotta know where you're starting, and that's I guess the drawback of the recursive formulas. You constantly have to know what the first term is, right? Whereas with the explicit formula, we don't have to. Okay, so all right. Well, not always. All right. Now, let's move on then. All right. What's the next thing? All right. Now, when I saw this, okay, let's see. Given the first term and common difference. They want the first term and common difference. Okay, the lights just went off. Hold on. All right. So given the first term and common difference, all right, they want to find the recursive formula and the 3 terms. It's the exact same as the last one, okay? Now, when I saw 19, I was kind of upset because of all the questions that I could give myself. I have to pick one with a fraction. All right, so I'm trying to save a little bit of time, so let me show you this, okay? I know it sounds like a cop-out, right? All right. All right, so, all right, you know what time is it anyways? Oh, actually, you know what? All right, I'm just going to do this. All right, so let's see. Recursive formula. Okay, so, and they want the first 3 terms. Now, I thought this was, like, hilarious when I saw this, because they want, the recursive formula requires us to give the first term. But look, the answer is right here. I mean, how many questions will you take, right, in your lifetime in math where part of the answer you just copy straight from the question, okay? All right, you can't make this stuff up. All right, so again, a to the n, right? And then the previous term minus the common difference. That's it. I can't believe this. Okay, turns out there's like no math required. Okay, so that's it. That's the formula. All right, so basically this question tests you to see if you know how to like read and if you know how to write. Okay, all right, jokes aside, all right, next one. Again, the first term is 26, and so the nth term will be the previous term plus 200. That's it. Boom. All right, moving on. Oh, I didn't list the 3 terms, did I? Oh, oops. That's why. The 3 terms after the last one's given. So they want to, A2, A3, and A4. Okay, all right, totally forgot. Got too excited. All right, so let's see. That's first term minus a third. Right, so that would be, man, this is a blast from the past. 4/15, all right. This one is 4/15 minus a third. All right, 4/15 minus, let's see, wait, 3 times 5, 5, negative 1/15. And then this one is, let's see, what is that? Negative 1/15 minus 1/3, negative 1/15 minus, let's see, 15, 3 times 5, negative 6/15, which I think we could reduce, which is negative 2/5. Okay, that's it. Now, knowing that, I'm gonna skip this one, okay, because this is just straight up adding. So I'm trying to save some time for you and me. Okay, now this is as far as I'm going to take you here with these last two questions. Now, I don't know if you've noticed, right? So if you were to try to write this based on what I've shown you above, then you might look at this and say, oh, Mr. Ring, that's easy. A's of n is A's of n minus 1, right? Plus the common difference, which is 0.6. But then here's the problem. Remember the part where I said you can just copy it for the first term? Uh-oh. There isn't a first term, right? Now, I'm kind of debating this as I'm doing this because I have yet to see a question on the regions that wants you to give them the recursive formula without giving you the first term. But just in case, right, they're trying to be slick, I'm trying to show you that, this is how you can do it. We can go back to the formula for explicit. All right, so we have to use our previous knowledge here. So remember this equation, right? So let me just copy can I just copy and paste this? Yeah, of course. All right, I'm gonna copy and put this down here. Is that it? Yep. Is that it? No, it's not. It's from a previous lesson. All right, and I could paste this over here. Right, and I could just follow this along. All right, I'm going to cover number 25 for a second. Right, so for example, right, this is how you can solve it. All right, if I have the 21st term already, right, I can use this formula to solve for the first term. So watch this, okay, and then I'll let you try the next one, and then we'll be done for today. A's of n, now here I want the A's of n, which is 21. Okay, so I'm basically setting them the equation using what they gave me, which is this and this, right? So look. A's of n is negative 1.4 equals first term, which is what I'm looking for, plus the number of terms for this is 21, right? So this is 21 minus 1, all right? And then times the common difference. Now, look, this is actually great because like now we only have one variable to look for, right? So I'm going to just keep solving this like a good old equation. Still looking for a first term plus 20 times 0.6. Now I'm going to move this to the side. 0.14, negative 0.14 is a to the first power plus 20 times 0.6 is 12. Oh, look, good old one-step equation. All right, this is negative 13.4, and this is a first. That's it. That's how you do it, okay? So with that said, I'm gonna move this here, all right? Because this one, I would like you to try on your own, okay? So let me get a different color. Press pause and try it now, so press pause right now. Okay, all right, and we're back. Now, same thing, right? I'm gonna use this good old formula, by the way, which is provided on the regions, okay? So this is the only time that you pretty much need this formula, all right? Let's see. A's of 18 is 27.4, right? First term is what I'm looking for, plus n minus 1, which is the 18th term before that, times the common difference. Okay? Now this is 27.4 equals the a to the first power plus 17 times 1.1. Let me check out what that is. The day's about to start, actually. 17 times 1.1, which is 18.7. Subtract 18.7 from both sides. What's that? What's 27.4 minus 18.7? All right, I'm working I'm working really fast here, okay? So, okay, all right, look, first term, 8.7. The second thing is A's of n is the previous term plus the common difference. And voila, that's it, okay? So we're not gonna do 27, all right? There's no need for that. Maybe I can do it, like, you know, if there's extra time in class, but not on the video. Okay, so that's it. So this is the only day we're gonna spend on this. Tomorrow, we're gonna do geometric, recursive formulas, and then that'll be it. Okay, all right, thanks for watching. Have a good day. Oh my God, all right, bye. OMG, that was so good.